All right, so we're going to go through a force of friction sample problem like we've been working on in class. So here's the problem. It says calculate the acceleration of a 10 kilogram box being pushed across the floor with a 200 Newton applied force and a coefficient of friction of 0.2. First step, as we've discussed, is to write down what you know. So we know that our mass is 10 kilograms. We know that our applied force is 200 newtons. We know that mu, or the coefficient of friction, is 0.2. And remember, there is no unit for coefficient of friction because it is just a coefficient, a ratio of the force of friction to the normal force. And acceleration is what we're solving for. So that's what we know just by reading the problem. Next, we're going to make a plan. Okay, so in order to solve for acceleration, we know we need to use Newton's second law, which is F equals ma. But the F in that equation is the net force. We don't know the net force yet. So in order to find the net force, we need to know all the forces acting on the object because the net force is just the sum of the forces acting on an object. So we're going to figure out all the individual forces, add them up to find the net, and then we're going to use the net force with the mass that we already have, and we're going to use that to solve for our acceleration. So after we've got our givens and our plan, we're going to write down our calculations. So first thing we can do is solve for the normal force and the force of gravity. And in this case, since there is no vertical acceleration, we know that gravity and the normal force are going to be the same. We do that by essentially calculating the weight, which is mass times acceleration due to gravity. Our mass is 10 kilograms. Acceleration due to gravity is about 10 meters per second squared. And we are going to use that to calculate a normal force of about 100 newtons. The force of friction can be solved by using the coefficient of friction equation that we've already discussed, rearranged solving for force of friction. We've got force of friction equals the coefficient of friction times the normal force, or 0.2 times 100 newtons, and that gives us a value of 20 newtons for our force of friction. Now, we've got our applied force, which was given to us in the problem. We've got our force of friction, which we just calculated. We've got the normal force, and we've got gravity. And we find the sum of all these to get our net force that we can then go back and use to find the acceleration. Now, make sure you realize that the force of friction is negative because it's acting opposite the applied force, and also that the force of gravity is negative because it's acting down, and we consider down to be a negative direction. So as you look at this problem, you'll see that the normal force and gravity are just going to cancel because they're both 100, and one is positive and one is negative. If I add 100 newtons to negative 100 newtons, I get 0. So those just go away. So as I simplify this a bit, what I've got is my force of friction plus my applied force is going to equal my net. Now, again, the force of friction is negative because it's acting in the opposite direction of the motion. So I'm going to take negative 20 newtons plus 200 newtons that was given to us in the problem, and I'm going to get 180 newtons for my net force. And then with that, I can just use Newton's second law, rearranging it to solve for the acceleration. And I get 180 newtons over 10 kilograms, or 18 meters per second squared is my acceleration. If you're still looking for a little bit of additional help besides that tutorial, I'd check out a couple of these resources that we've got here. I've showed you these in class before, but they're very helpful. One is Bozeman's Science video list. You can check out all the videos on forces there, particularly the ones on contact forces. And then physicsclassroom.com has some Newton's laws and forces tutorial that are going to be really helpful.